Chapter 2, Exercise 11. Show that for any sets A and B, A is equal to the union of A intersect B and A minus B, and that A union the set B minus A is equal to A union B. Okay, let's do these one by one. I'm going to use the same approach I've been using this whole time, just show that they're subsets of each other. So, A equal to A intersect B union minus B. And the first thing I'm going to do is say this as our first sub goal. All right, so let's suppose X is an element of A. Then for any element in whatever set you want it to be, it either has to be in a set or it has to not be in a set. It can't be both, it can't be neither. Then either X is in B or X is not in B. So if X is in B, then X is in A and X is in B, which is equivalent to saying that X is in the intersection of A and B. Then this implies, of course, that X is in A intersect B union A minus B. And then if X is not in B, then X is in A and X is not in B, which is equivalent to saying that X is in the difference of A and B, which implies that X is in A and B union A minus B. So A is a subset of A intersect B union A minus B. Cool. Now we have to show that the converse is true, namely that A intersect B union A minus B is a subset of A. And it's pretty much the same proof, but actually it's even easier. So suppose X is in A intersect B union A minus B. So if X is in A intersect B, then X is in A, and then that's pretty much all we wanted. If X is in A minus B, then X is in A. So regardless, um, so A intersect B union A minus B has to be a subset of A. Thus, A is going to be equal to A intersect B union A minus B. Cool. Now let's add a new page. All right, and the second problem we're supposed to solve is this one. A union B minus A is equal to A union B. All right, so once again, let's do the first subgoal, and I'm actually going to do them backwards this time. A union B is a subset of A union B minus A. All right, so let's suppose X is in A union B, right? Then either X is in A or X is in B or both. If X is in A or Alternatively, if x is in A and B, I'm going to consider both of these simultaneously, then clearly x is in A. So x is going to be in A union B minus A. And then that last case we have is if x is not in A, but x is in B, then x is in B. I'm just rewriting it. And x is not in A. Rewriting it in our formal language, that is. So x is in B minus A, which implies that x is in A union B minus A. Cool. Thus, A union B is a subset of A union B minus A. Okay, cool. And now the second thing we're supposed to show is that A union B minus A is a subset of A union B. And this one is a lot simpler because if we suppose x is in A union B minus A, then x is in A, or x is in B minus A, right? And then, or both, but we only need to consider these two cases. If x is in A, then x is in A union B. And then if x is in B minus A, then x is in B, which implies that x is in A union B. And there we go. The only two options, or rather, look, I only consider these two options because that's all you need to do. You don't need to always consider the case when there's both. I did it here because it can get a little bit ambiguous how exactly this case, where it fits. But I digress. We only need to consider these two cases. But actually, let me just do it. If x is in A and x is in B, then x is in A, which implies that x is in A union B. Usually the case where you consider both things being true is a subcase of one of the two being true. You just have to figure out which one if it's not completely apparent at first, which is what I did in the first subpart of this. So regardless, either way, A union B minus A is a subset of A union B. Thus, we conclude that, A union B minus A is equal to A union B. Sorry for the bad handwriting at the end. I hope it's legible. But anywho, this is it for exercise, what was it? 11. So, hope this was helpful, and I will see you in the next video. Bye bye.